Gute. I'm still trying to find ways to improve the way TTS pronounces words. And for that I'm learning about phonemes and possible alternatives. And I'd like to share with you what I've learned so far. And according to Shakespeare's Hamlet or Hamlet, I'm going to call this video Phoneme or not phoneme. That is the question. Sorry.
Gute. Hacky techy nerd stuff. Open voice enthusiast. Open voice, open future.
We look to Koki TTS official documentation. And search for phonemes. And there we will find an important parameter, and that is called use phonemes. And as you can see, it's a Boolean value, so it's true or false. In this case of documentation, it's set to false. You can take a look to Koki TTS receipts folder, and you will see some configuration. For some languages it is set to true, and for some other it's set to false. Personally, I would recommend to use phonemes, as I think it will lead to better and more natural results. And important is, there is not a global magical black box for phonemes for every languages in the world. So phonemes is a language specific and individual thing. But if I'm right and using phonemes will produce better results, why isn't it set by default to true? Or if it is set to false, what's happening then? What is the alternative if it's set to false? And in my case, at least at the point of understanding I'm right now, I think that if you set it to false, it will not use phonemes, obviously. Instead, it will use a character-based training. And character-based training will try, or in a character-based training, the TTS training process will try to learn how characters or combinations of characters are pronounced. But because characters or combination of characters might be pronounced different from one word to another, it might lead to less natural results. But why should I set it to false? And to get an idea of that, we should think on which phonemic backends does Koki TTS support right now. And in my honest opinion, there are two, maybe 2.5 components supported. One is Michael Hansen's great work called Groot. And the other one, or 1.5, is eSpeak or eSpeak NG, depending on your local system configuration or what component did you install. And as I think right now, eSpeak or eSpeak NG is really widely known and supported. Let's just check how many languages does eSpeak NG support for doing that magical phonetic stuff. So jump over to eSpeak's GitHub repository. It supports more than 100 languages, and in detail it means eSpeak NG supports 127 languages. To get an idea if that's good or not, let's just ask the internet. Number languages world. How many languages are in the world? There are about 7,000 languages spoken in the world. I had not validated this number, so I'm not sure if this is correct, but even if eSpeak NG now supports some languages more, And even if that 7K value isn't really correct, which I haven't validated, you get the idea. There is a huge gap of languages supported by one of the most famous phonemizing backends, eSpeak-NG, and the number of languages spoken. So if you would like to train the TTS model for a language, for the majority of languages that are not supported by either GRUD or the widely known eSpeak-NG, you have not the option to set it to true. You have to use character-based training. So that is probably one reason why you can set the parameter of using phonemes to false. And if you train the TTS model for a language that is supported, in that case by eSpeak or eSpeak-NG, you have to set two additional parameters. One is the language code and one is a phoneme cache directory. I'm going to show you some stuff more in that phoneme cache directory later on. But to sum it up for character-based training, if you have to set using phonemes to false, you can run a simple helper script called find unique characters, pi. I'm going to show you in a second, to get a list of unique characters. And this output of the helper script you can copy and paste into your configuration for model training. So for that, let's switch to our Visual Studio Code. To run that simple helper script, at least I have already written a config.json file for model training, and because that's a requirement to run the helper script. So let's run the little script, which is in the TTS bin folder where all the helper scripts are in, and let's run find unique characters with a parameter called config path and your configuration JSON. So that's the output of the simple helper script. It will check your complete data set, which is configured in the config.json file, and will print some unique characters. And this content should be part of your config.json when you run a character-based TTS model training. But let's go back one step. If we set use phonemes to true, we have set the language, we have set this mysterious cache path. So when you have started your training, the TTS training will create this output folder called phoneme cache. And let's take a look. It will create a phoneme numpy file for every recording you have in your voice dataset. You can take a look into the file, but it's not a really helpful output like that, because as you can see, it's not really helpful. But what you can do is, or what I have done, I have created a super simple Python row line. Calling it a script would be way too much. So you can just use numpy, load the file and print the results. So let's just run it, and it will return a simple numpy value array. And honestly, right now, I'm not quite sure on how to understand these values. But what I've understood so far is that for every recording in your voice dataset, such a phoneme, a numpy file is created upon starting a new training. Now I would like to show you some places in the code, not for a deep dive within that video, but maybe if you would like to jump more into that topic yourself, these snippets or these code parts might be worth a look to get started. So let's minimize that one. In the file dataset Python, there is a method called compute or load, which should be worth a view. And here's checked if there is a phoneme numpy file, as we have seen in that phoneme cache directory. It will load the numpy content if it's found, or in case it's not found, it will run a tokenizer text to IDs. And if you jump to a tokenizer Python file, you can see this method text to IDs, which is doing some of these steps of text normalization, phonemization, and stuff like that. We have a file called groot wrapper Python, and in that file we have a method called phonemenize groot, and this is the place where the groot magic seems to happen. I will dive more into detail myself, and if I have built up enough knowledge, I would like to share it with you, as always. Yeah, and I think that might be a good ending for today's video. If you liked that video, please feel free to give it a thumbs up, or share the video, or if you like the content I'm doing here, you can easily support my channel if you subscribe to it. So that's it for now, and we will see us next time. Bye!